Hi, I'm Dr. Catherine from ChemPraxis. Today, I'm going to discuss Chemistry Paper 4, 0620, Paper 42, February-March 2024 papers. For the first question, iron ore contain iron trioxide. A blast furnace is used to extract iron from iron oxide. Equation for some of the reactions in the blast furnace are shown. We have equation 1, carbon react with oxygen to form carbon dioxide. Equation 2, calcium carbonate thermal decompose to form calcium oxide and carbon dioxide. And for equation 3, calcium oxide react with silicon dioxide to form calcium silicate. So for question A, equation 1 shows the combustions of carbon in the blast furnace. Name the substance which provide the carbon for this reaction. The substance that provide carbon is coke. And for the second question, state the purpose of the combustions of carbon in the blast furnace. For this reaction, it is exothermic, so they provide heat for the blast furnace. For the question B, iron oxide in iron ore is converted to iron when it reacts with carbon monoxide in the blast furnace. Calculate the percentage by mass of iron in iron oxide. In order to find the percentage of iron in iron oxide, first of all, you need to find the atomic mass of iron in iron oxide. Then you can over the relative molecular mass. Then you times 100% in order to get the final answer. And for Roman 2, state the name of the iron ore which consists mainly of iron trioxide. We usually call iron trioxide as hematite. And describe how carbon monoxide is formed in the blast furnace. Usually carbon monoxide is formed when carbon dioxide react with carbon to form this. And Roman number 4, write the symbol equations to show the reactions occurs when iron trioxide is converted to iron in the blast furnace. We can use the carbon monoxide as a reducing agent in order to react with iron oxide. Then we will get pure ions and also the carbon dioxide. And then name the chemical process which happens to iron when iron trioxide is converted to iron in the blast furnace. Since your iron oxide lose oxygen, in this case, it is reduction. Then for question C, state the type of reaction shown by equation 2. For equation 2, your calcium carbonate is thermally decomposed to form calcium oxide and carbon dioxide. So this process we call it as thermal decomposition, means that you are trying to use the heat in order to break down a compound to form something simpler. Okay, so for question D1, explain why the reaction in equation 3 can be described as an acid-base reaction. For calcium oxide, it is a metal oxide. So for metal oxide, they are usually basic oxide. And for silicon dioxide, it is a non-metal oxide. So for non-metal oxide, they are acidic oxide. So when you have basic oxide react with acidic oxide, we call this as an acid-base reaction or neutralizations. Then for question D, Roman 2, state the chemical name of SiO2. So SiO2, you can call it as a silicon dioxide or silicon 4 oxide. Please don't forget to write the Roman number. And the common name given to CaSiO3 when it is formed in the blast furnace, for common name, basically we cannot give the chemical name. Chemical name is calcium silicate, but for common name, we call it as slag. Then for question E, aluminium cannot be extracted from its ore using a blast furnace. Suggest why aluminium is not extracted from its ore using a blast furnace. Because in order to extract iron, we use carbon. But in terms of the reactivity, carbon is less reactive than aluminium. So that's why it is not suitable to extract aluminium. Name the process used to extract aluminium from its ore. We usually use electrolysis. For example, if you have molten aluminium oxide, and this molten aluminium oxide, they will form free moving ions. The O2 minus, they will move to anode and they will form oxygen gas. While for your aluminium, they will move to cathode, and this aluminium ion, they will receive 3 electrons in order to form aluminium metals. Both iron oxide and aluminium oxide contain metal ion with a 3 positive charge. Write the electronic configuration of an aluminium ions. So for aluminium, before that is 283, and after donating 3 electrons, they will become 28. Deduce the number of protons and electrons in iron 3 plus ion. The proton is 26, and for electrons, since they donated 3 electrons, it will become 23. For the second questions, the elements in group 7 of the periodic table are known as the halogens. Halogens can form halide ions. Identify the halogen with the lowest density at room temperature and pressure. We choose fluorine because fluorine have the smallest mass number or smallest relative atomic mass. So when they have the smallest mass number, usually they will have the lowest density, since density's formula is mass over volume. And state the appearance of bromine at room temperature and pressure. Usually for bromine, it is a brown liquid. If you want to write orange brown liquid, it's fine. And for question C, use the periodic table to give the symbol of the halogen with the highest atomic number. If you go to the periodic table, we will choose the one lowest. I mean, like, can I say lowest? It's like the bottom of the group 7. Yeah, which is TS. And then deduce the number of occupied electron shell in an atom of this element. The number of occupied electron shell, this one we need to refer to the period number. If let's say I go to the periodic table, so for periodic table, okay, over here, let me rotate the page. So just now we choose TS. Okay, TS is the one that the bottom one. And then after that, in terms of period, we will count this as period 1, period 2, period 3, period 4, period 5, period 6, and period 7. So for period 7 means that they have 7 electron fuel shell. Now we come to question 2D. Bromine molecules have covalent bond. State what is meant by the term covalent bond. We can write sharing of electrons. And then name one halide ion which bromine molecule can displace. Usually bromine molecule can displace iodide ion. For example, if I have potassium iodide, react with bromine, since bromine is more reactive than iodine, they can displace iodide ion. Then you will form potassium bromide and iodine. Okay, then for question E, name a halide compound which can be used to detect the presence of water. If you want to detect the presence of water with halide ion, usually we will use anhydrous cobalt 2 chloride. And this anhydrous cobalt 2 chloride, they will become hydrated cobalt 2 chloride, which the color will change from blue to pink. Then now for question F, calcium fluoride is an ionic compound. Complete the dot and cross diagram in figure 2.1 for the ions in calcium chloride. Give the charges on each of the ion. For chlorine, before that is 287. And when they form chloride ion, they receive 1 electron from calcium. And same goes to calcium, because for calcium, before that is 2882. And they will lose 2 electrons. And the electrons that they lose or they donate, they will receive by each chlorine. And don't forget to write the charge. For Cl is -1 charge. And then for calcium, it is 2 positive charge. For the next question, aqueous lead ions are added to aqueous chloride ion. A white precipitate of insoluble lead 2 chloride is formed. Name a lead compound which can be used in this reaction. Usually, I would like to recommend students to use lead nitrate because all nitrate salt are soluble in water. Okay, so in order to make insoluble salt, we usually need to mix two solutions. So lead nitrate can make a solutions. For the second question, write the ionic equation for this reaction, include state symbol. Usually is for ionic equation for precipitation, the Pb2 plus. In the aqueous solution, they will mix with the halide ion, the chloride ion in this case. Also aqueous solution, you mix the two solution to form the insoluble salt. So for this, it is in solid state. And name one other insoluble chloride. Our favorite, usually silver chloride. For question 3, this question is about acids, bases, and alkalines. Table 3.1 shows the pH value of some substances. So we have sodium hydroxide, which is pH 14, calcium hydroxide, which is pH 10, water, neutral, ethanoic acid, pH 4, nitric acid, pH 1. So define the term base, you need to write proton acceptor. So please don't write pH more than 7, can react with acid. Because for base, the correct definitions should be proton acceptor. State what is meant by the term alkaline. Alkaline means that they are the base that can dissolve in water, so we call this as a soluble base. Timophthalin is an indicator. State the color of timophthalin in sodium hydroxide. Usually for timophthalin, they will give you blue color when they are in alkaline solution, and they are colorless when they are in acidic or neutral solution. Now we come to question D. Use the informations in table 3.1 to identify the substance with the highest concentration of H plus ion. Explain your answer. Usually for highest concentration of H plus ion, we will choose strong acid. Because for strong acid, they will ionize completely. Means that if let's say I have 0.1 mole per dm cube of nitric acid, they will fully ionize and they will give me 0.1 mole per dm cube of H plus ion as well. And then name an indicator which can be used to identify the substance with the highest concentration of H plus ion. So for the indicator that you can use to identify strong acid and weak acid, there is only universal indicator. So for universal indicator, they will give you red color for strong acid, and they will give you orange color or yellow color for weak acid. So now we come to question E. Complete the equations to show the dissociation of ethanoic acid in aqueous solution. So for ethanoic acid, which is a weak acid, you need to show the reversible sign. Reversible sign is very important, and they will form CH3COO minus and H plus ion. So for question F, write the ionic equation which represent a neutralization reaction between any acid and any alkaline. So usually for acid, we will use H plus ion to represent it. And then for OH minus, it represents alkaline. And when both of these react, they will give you water, which is neutral. For question G, dilute nitric acid react with aqueous calcium hydroxide as shown. 20 cm cube 0.015 mole per dm cube calcium hydroxide reacts with 25 cm cube of nitric acid. Calculate the concentration of nitric acid in gram per dm cube. Use the following step. First of all, we need to calculate the number of mole of calcium hydroxide used. Usually, I like to use N equals to CV over 1000. N stands for number of mole. C stands for concentration, V stands for volume. We divide 1000 because we want to change cm cube to dm cube. So with this formula, we find the number of mole of calcium hydroxide, which is equals to 0.0003. To determine the number of mole of nitric acid which react with the calcium hydroxide, the mole ratio is 1. For nitric acid, the mole ratio is 2. So I put the mole ratio 1 and 2 here. For the number of mole of calcium hydroxide is 0.0003. And then for nitric acid with the ratio of 2, we can use 0.0003 times 2, then we will find the number of mole of nitric acid, which is equals to 0.0006. And the next question, calculate the concentration of nitric acid in mole per dm cube. Usually for the calculation of concentration, I always use this formula, N equals to CV over 1000. I put the number of mole here, 1000 here, and 25 here. So the final answer is 0.024. And the last question, calculate the concentration of nitric acid in gram per dm cube. It is not hard to change mole per dm cube to gram per dm cube. What that you need to do is just to use the mole to times the mR so that you can change it to mass. So I find the mR of nitric acid, then I get the final answer. So for question 4, the equations for the reactions between methanoic acid and ethanol in the presence of a catalyst can be represented as shown. So this is the methanoic acid, this is the ethanol, and they will form X and also water. And this reaction is an exothermic reaction with negative 29.5 kJ per mole. X represents the ester form. For A1, in the equations, methanoic acid is represented by the formula HCOOH. Name this type of formula. We usually call this as a structural formula. Means that they're trying to show the structure of the organic compound. And write the empirical formula of methanoic acid. For methanoic acid, the molecular formula is CH2O2. Molecular formula show the actual number of each element. And for empirical formula, usually they show the simplest ratio. However, this molecular formula cannot be simplified. So the molecular formula and the empirical formula, they are the same. Then the next question, name and draw the display formula of ester X. For display formula, please remember that you need to show all the atoms and all the bonds. So when the ethanol react with methanoic acid, they will form ethyl methanoate. We usually will name alcohol. So in this case, the ethanol, they will become ethyl, and then the methanoic acid, they will become methanoate. And in order to draw the structure, this is a condensation reaction. They will remove water. Before that, this is the structure of methanoic acid, and this is the structure of ethanol. So when they join together, we will remove the OH from the carboxylic acid and the H from alcohol. Then they will form water, and we will link these two together in order to form ester. Okay, then now for question C, the reaction is reversible and reach an equilibrium within a closed system. State what is meant by the term closed system. Closed system means that no reactant or product can escape. And then state two characteristics of an equilibrium. So the rate of forward reaction is equals to the rate of backward reaction, while for the concentration of both reactant and products, they will remain constant. For question Roman 3, complete table 4.1 to show the effect, if any, on the concentration of X at equilibrium for each change of condition. So this reaction is exothermic, and then this is the reaction that we see just now. The methanoic acid react with ethanol to form the ethyl methanoate to form water as well. So when the temperature is decreased, the effect of concentration of X at equilibrium, they will increase. Because for temperature, low temperature favor exothermic reaction. Since your forward reaction is exothermic, they will favor the exothermic reaction, they will favor the forward reaction, the amount of X will increase. And if the concentration of methanoic acid is decreased, in order to oppose the change, when the concentration of the methanoic acid decrease, they will try to shift the equilibrium to the left so that they can replenish or they can increase the concentration of HCOOH. And in this case, X will decrease. If the concentration of both methanoic acid and ethanol are decreased, if let's say both of them decrease, same thing, they will shift the equilibrium to the left and your X will decrease. If the catalyst is removed, basically catalysts have no effect on the shifting of equilibrium. So in this case, they will have no effect on the concentration of X at equilibrium. For question 5, butane and butane are colorless gases at room temperature and pressure. Suggest why butane diffuse quicker than butane. In terms of diffusion, we usually depends on the relative molecular mass, which is MR. So the MR for butane is lower because if you check the molecular formula for butane, it is C4H10, but the molecular formula for butane is C4H8. So in terms of MR, this one the MR is lower. Identify the product formed when butane undergoes complete combustion. Complete combustion means that they have excess oxygen. So when you have excess oxygen, you will produce water and carbon dioxide. For the next question, one molecule of butane reacts with one molecule of chlorine in the presence of UV light. During the reaction, one hydrogen atom in butane is replaced by one chlorine atom. Name the type of reaction which needs UV light. We usually call it as photochemical reaction. For example, photosynthesis, which requires UV light as well. And then state the purpose of UV light during this reaction. They will provide activation energy to break the bond, for example, and then to let the reactions happen. And for Roman 3, name the type of reaction which takes place when one atom of chlorine replaces one atom of hydrogen. We call this as a substitutions reactions. Determine how many different structural isomers can form during this reaction. So if let's say butane, one of the hydrogen is substituted by chlorine, we can have two different isomer. The first one, we can have one chlorobutane, means that the hydrogen atom on the first carbon is replaced by chlorine. And we can have the second option as well. For the second option, the carbon atom that have hydrogen atom attached, the second carbons, they are replaced by chlorine. And for this one, we call it as 2-chlorobutane. So there are only two options or two structural isomers. So for question D, when butane reacts with steam, two possible products form. Identify the type of catalyst which is used in this reaction. The catalyst that we use for addition, particularly hydration, is phosphoric acid, H3PO4. And if let's say you want to know the conditions for this reaction, it is 300 degrees Celsius and 60 atmosphere. So for the next question, name and draw the display formula of the two possible products. Same thing, we will have the OH, for example. If let's say you are having a butane, when they react with steam, H2O, this H2O, they will have H and OH. If let's say your OH is attached to the first carbon, we will call this as a butano. And if the OH attached to the second carbon, you can call this as 2-butano, or you can call this as butan 2O. Both options are accepted in your mark scheme. Then for question E, butane undergoes polymerization. State the type of polymerization butane undergoes. Usually for the polymerizations that involve alkene, it is addition polymerization. For addition polymerization, usually they have only one product, or you can say that they have no byproducts. And draw parts of the polymer molecule to show 3 repeat unit. So this is put 1 in. And for put 1 in, usually before you draw the polymer, I will highly recommend you to rearrange the structure. And how do you rearrange the structure? You need to make sure that the double bond, okay, you try to put the double bond in the middle. Then for this hydrogen, you can put 1 hydrogen on top and 1 hydrogen is here. Same goes to this. This hydrogen is on top. And for this is a C2H5. So you need to put C2H5 attached to this carbon. After that, because they ask you to draw 3 repeat unit, means that I need to put 1 in 3 times. So this is repeat unit number 1. And this one is repeat unit number 2. And this one is repeat unit number 3. So this is 3 repeat unit. And you need to draw the extent, the bond extent, so that to show that this is a polymer. And this is the end of this paper. Thanks for watching our video. Please click the like and subscribe button for more past year paper explanation video. Thank you.